students, I am Nilanjana Senial. Welcome you all to my channel NS Online Math Classes. Our today's topic is the power law of logarithms proved using the product rule of logarithms. In fact, we will be having two video sessions on this power law of logarithms, and in both the sessions we will be having one method of proving this power law of logarithms. We will be in fact having or learning two methods of proving this law, and this will be the first one will be easier than the second one, of course, but the first one will be having some limitations. I'll be showing that. I'll be explaining that as well, and of course along with the proof we will be solving questions based on this power law of logarithms. Okay, so without any further delay, let us start with our today's session. First of all, let us know about the power law of logarithms. It is m times log of x to the base a equal to log of x raised to the power of m to the base a. This is the power law of logarithms, and it doesn't matter, since it is an equation, it doesn't matter which term you write on the left hand side. I have taken this term on the left hand side for this session. In our coming session, I'll be taking this term on the left hand side, because since it is an equation, it absolutely doesn't matter which one you are writing first. Okay? And now we come to the product rule of logarithms. Since we will be using this rule, what is that rule? And in fact, we have learnt about the product rule of logarithms, but again, I have written this in this session because we will be using this. Log of x to the base a plus log of y to the base a equal to log of x times y to the base a. If you have two log terms added together and both the log terms have the same base, then you can combine them to get a single log term which will be having the same base, and the argument of that log term will be the product of the arguments of the given two log terms. Okay, so this is the product rule. And now what happens if x is equal to y? When x is equal to y, the left hand side becomes log of x to the base a, plus in place of y I can write x. So it is again log of x to the base a. And what happens to the right hand side? It is log of x times x, because in place of y I am writing x. So it is log of x times x to the base a. And what is this equal to? Log of x to the base a plus log of x to the base a. Suppose log of x to the base a is equal to t. So it is basically t plus t, which should be equal to 2t. That means 2 times log of x to the base a. This is the left hand side. And what about the right hand side? X times x is x squared, or x raised to the power of 2. So we write this equation as 2 times log of x to the base a equal to log of x raised to the power of 2 to the base a. And you see, this is the equation that we have written in generalized form. If we take the value of m as 2, we get this equation. But does this mean that m has to be equal to 2 and m can have only the value of 2, and this equation will be satisfied only when m is equal to 2? Let's see. For that, let us add log x to the base a to both the sides of this equation 1. And what do we get? Log of x to the base a plus 2 times log of x to the base a will be equal to log of x to the base a plus log of x raised to the power of 2 to the base a. And this side will obviously be equal to 3 times log of x to the base a, because this is t and this is 2t. t plus 2t is 3t. So this side, the left hand side, is 3 times log of x to the base a. And for the right hand side, we will be using the product rule. We are having two terms with two log terms with the same base, and they have to get added together. So we will be combining these two log terms to get a single log term with the c in base a, but the arguments will get multiplied together. So it will be x times x squared. So we get 3 times log of x to the base a from the left hand side, which is equal to log of x times x squared to the base a. And what is x times x squared? It is log of x raised to the power of 3 or x cubed to the base a. So this time we are seeing that the m is having a value of 3. And this is a very easy proof. You can just go on adding log of x to the base a, and you will be seeing that every time we are getting, if I add log of x to the base a to this equation, I'll be having an equation which will be giving the m value as 4. It will be of this type, and the m value will be equal to 4. So this way you can show that this power law is valid for every positive value of m. But for if we have x raised to the power of, say, -1 or -2, any negative number, then it becomes slightly difficult. So that is why I have made 2 videos, and I have shown this proof of the power law of logarithms using the product rule of logarithms, and I will be showing the proof of the power law of logarithms in general as well in our coming session. Okay. So this is when generalized we get m times log of x to the base a equal to log of x raised to the power of m to the base a. That is the power law. Okay. Now coming to one of the questions based on, of course, the power law. Given log of 20 to the base 10 equal to 1.301. Of course, if you are having a calculator, you can find this value using the calculator, but this question assumes that you don't have a calculator, so they are giving you this value. Log of 20 to the base 10 equal to 1.301. And find the value of log of 20 raised to the power of 2 to the base 10. So we are given this value, we have to find this value. Over here we are having a power of 2. So of course, since we are having a power in the argument, we will be using the power law. So what do? Log of 20 squared to the base 10 can be written as 2 times the power comes down to the coefficient place. That is the power law. So it is 2 times log of 20 to the base 10. And we know the value of log of 20 to the base 10, it is 1.301. So this is equal to 2 times 1.301, which is equal to 2.602. So the value of log of 20 squared to the base 10 is equal to 2.602. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you have found this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.